So in this video, we're going to see how to go from a graph to an equation. If you're looking at a graph and you say, hey, that looks like a parabola, so I bet the equation for that graph is y or f of x equals something times x squared plus something times x plus something. But what are the somethings? Well, go back to that standard form. Y or f of x equals a times x minus h squared plus k. If we could fill in the correct numbers for those three letters, a, h, and k, we'd have an equation. And right away we can fill in the numbers for h and k, because those are the coordinates of the vertex. So I see what the vertex is for this parabola. It's -2, -2. So let me go ahead and stick in -2 in place of h and -2 in place of k. And it looks a little awkward to write x minus -2. Let me just write that as x plus 2. And instead of writing plus -2 on the end, I'll just write -2. So it's y equals a times x plus 2 squared minus 2. The only thing left to figure out is what number has to go here for a. I can at least tell it's got to be a positive number, because this is the kind of parabola that opens upward. But is it positive 1 or 2 or 1/2 or something completely different? For that, we need another point. They've conveniently labeled another point that we can use. So one of the other points on the graph is 0, 2. That means that when x is 0, then y, or f of x, has to equal 2. So this equation ought to be true if I plug in 0 for x and 2 for y. Or sometimes it's written with an f of x over here, 2 for f of x. Look at that. All those numbers, the only unknown left is a. Let's try to do some algebra here and see if we can solve for a. First of all, inside the parentheses, 0 plus 2 would just be 2. And then 2 squared would be 4. So we're looking at the equation 2 equals 4a minus 2. To finish solving that, I would add 2 to both sides, so 4a equals 4, and then divide both sides by 4, so a equals 1. So remember, we had y equals a times x plus 2 squared minus 2. Now we can go back and replace that a with the number it actually is, 1. And we have our function. Y equals 1 times x plus 2 squared minus 2. Of course, you don't have to write the 1. You can just say x plus 2 squared minus 2. You can call that y, or you can call it f of x. You could say f of x equals x plus 2 squared minus 2. And you could either just leave it like that, or you could multiply it out if you wanted. X plus 2 squared, if you multiply it out, would be x squared plus 4x plus 4. And then if you minus 2 from that, you got x squared plus 4x plus 2. So that's another way you could write it. But if you just get to this, that's good enough. Let's try another example. Try to find an equation or formula or function for this parabola. Remember, here's our starting point. Y equals a times x minus h squared plus k. Now, what numbers am I going to be putting in place of the h and the k? I see my vertex is -3, 3. So for h, I'll put -3, and for k, I'll put 3. Y equals a times x minus -3 squared plus 3. And instead of writing minus a negative, I'll write it as plus a positive. Y equals a times x plus 3 squared plus 3. Now to finish finding what a is, we need another point. They've helpfully pointed out that another point on the graph is negative 2, 1. So when x is negative 2, then y is 1. So we ought to be able to take this equation and put negative 2 in for x and 1 for y, the thing that this whole thing is equal to. So 1 equals a times negative 2 plus 3 squared plus 3. Okay, let's work on that and try to get what a has to be. Inside the parentheses, negative 2 plus 3 would be just good old positive 1. And 1 squared would be 1. So now we're looking at 1 equals 1a plus 3. Subtract 3 on both sides and you get 1a, or just a, equals negative 2. So our equation, our function, or what f of x or y has to equal is negative 2, because that's what we got for a, times x plus h squared plus 3. Now, if you want to look at this geometrically, think about what was going on here geometrically. What we're doing here is we're trying to get a parabola that has its vertex here, and then it also includes this other point. So if I start with my y equals a times x minus h squared plus k, I need to adjust the a and h and k to make that work. So first let me adjust the h. Let me slide this over horizontally until the vertex is in the right place, and then slide it vertically so the vertex is in the right place. And by the way, look, h ended up at negative 3 and k ended up at 3. So there's my vertex. Now I'm going to try to adjust a so that the parabola does pass through this point negative 2, 1. There, that did it. And what a did it? That happened when a was negative 2. So if I want a parabola with a vertex here and another point here, a has to be negative 2, h has to be negative 3, and k has to be 3. Let's try one or two more of these to see if we've got the hang of it. Determine the quadratic function whose graph is given here. Okay, take our starting point, that standard form a times x minus h squared plus k. What numbers will we put in for h and k? The coordinates of the vertex, 5 and 0. So y equals a times x minus 5 squared plus 0. Or just a times x minus 5 squared. And by looking at this other point on the graph, and really you can pick any point on the graph besides the one you already used for the vertex. Here they just labeled one other point, but if we knew a different point that was also on the graph, we could use that instead. It doesn't matter which point you pick, just any point on the graph other than the vertex that you already used. So here we're using the point where x is 3 and y is negative 8. So negative 8 equals a times 3 minus 5 squared. Well, 3 minus 5 would be negative 2. Negative 2 squared would be 4. So 4 times a has to equal negative 8. Therefore, a has to equal negative 2. And I can come back up here and rewrite this equation, but with the actual number negative 2 in place of that letter a. So y equals negative 2 times x minus 5 squared. And here's one where we don't have a graph to look at, but we still have all the same information. The vertex is at negative 3, 5, and then another point on the graph is negative 6, negative 1. So start by putting in the coordinates of the vertex for the h and the k. Y equals a times x minus negative 3 squared plus 5. which simplifies a bit to y equals a times x plus 3 squared plus 5. Now we know that when x is negative 6, then y has to equal negative 1. So putting those numbers in for x and y, negative 1 equals a times negative 6 plus 3 squared plus 5. Inside the parentheses, negative 6 plus 3 would be negative 3. And negative 3 squared would be 9. So we have negative 1 equals 9a plus 5. Subtract 5 on both sides, and we get 9a equals negative 6. Divide both sides by 9, and we get a equals negative 6 divided by 9, which simplifies to negative 2 over 3. So the number we got for a turned out to be a fraction, but that can happen. It was negative 2/3. So the equation is y equals negative 2/3 times x plus 3 squared plus 5. This is an exact copy of what I wrote way back up here, except that now I've filled in an actual number in place of that a.